Hi, I'm Beagle Bridge from XinaBox, and I'm going to talk about two new kits, two new expansion kits for the XK07 and or XK90. So the two kits, the one is a hardware extension kit. You also have a software extension kit. So let me go through it with the different elements there is in a kit. So first of all, you will find a lot of videos, a lot of material already. So a lot of other YouTube videos and a lot of other links to the different libraries. I will put some of those stuff in the comments in the section below, so you can easily find it. So let's look at what's in the different kits. So the first thing is a hardware extension kit, and for the hardware extension kit, you are going to need a flathead screwdriver, a little one like that, and or a solder station. So just be aware that when you normally use XinaBox and X chips, you can just click them together. With a hardware extension kit, that's a different X chips where it might need a little bit more. So the first one up is our XK01. So this is a chip that looks like this. And it breaks out all the different pins. So there's like 6 pins here and 6 pins here and 5 pins here, 5 on both sides. So you will have all the pins here, all 16 pins broken out here. So if you have something that's not fit in with the XinaBox ecosystem, but you still want to kind of like use XinaBox to communicate with it, then you can use that. So what you're getting is that you get this one here, but these pins are not soldered on. So you have to solder those pins on, because you might want to have them on the top side. You might not want to have pins because you have something else that have pins already. You might not want all the pins, but you're getting these pins along, and you can then plug it into a breadboard like this thing here. That is not coming along, but this one here is there. So if you, for example, let's say you have, this is an ultrasonic sensor, you can plug that in, and then you can wire it from the one side to the other. There is not a lot of external pins here. Actually, there is no GPIO pins in general, but you can use the SCL and SDA pin. You can probably use the RX-TX pins, depending on what you have here on the other sides. The next one that comes up is the XK01. So this is an 8-bit ATC. It have like address selection, so you can put a lot of these ATCs in a row. Of course, you can just click them together like X chips normally, but you have an opportunity here to connect a little analog circuit that provides between 0 and 3.3 volts. So there's no power coming from that. You simply have to provide a power source from 0 to 3.3 volts. So you can have a resistor, and you can get power, for example, with the XK01 or wherever you have, and then put that in. There's a little third pin here, NC for not connected, that just helps you kind of like connect the different things together if you need another little screw terminal. So that is the XK01. And as I said, it's an 8-bit ATC, nothing fantastic, but hey, it gives you a value between 0 and 255 when you want to measure something. Then we have a SU02 digital input. That's a little bit more straightforward. If you shorten these two terminals here, this thing here will come back and say true or on or whatever, high, and if there's nothing connection, it's low, false, 0, the other end. So this is like a digital input. And if you, for example, have like big switch like this thing here, that's like a little security thing and all that kind of stuff, then I soldered like a couple of pins here, so I can put it into my breadboard from before, and then I can of course put a couple of pins in, and I can actually screw it in. So for example, here I have a SU02 where I just put 2 pins in, so I kind of like can put that into my breadboard. But you can of course put other terminals in, and it's a digital input. So whatever you have, you can may have a magnetic switch. You have something that tells you whether the gas door open or closed. You can put that in. Then we have the OCR1. We call it the burn wire module. And the reason why we call it the burn wire module is because it have MOSFETs on the 3 terminals here. So we have a little pin here that have to be soldered up there. I think it's soldered as default. And if it's soldered, then it will take 5 volts or whatever you have as your V source. So if you have USB power, then it will send the USB power out here, the 5 volts. If you, for example, have the PTO1, which you can see is a button, if you, for example, have 12 volt on this thing here, and there's a little V source that have to be soldered here if you want to use that power, then that comes out here. If you have the PBO4, which you probably have, and there we go. I have the PBO4 here. So in this PBO4 here, if you want that power to go straight out here, then there's a little thing here below you have to solder. You can see it. You have to just lift this a little bit here, and you can then solder just below here. There's a little point to solder. And now the 3 volts, you remember 2 times 1.5 here, goes out here. And that power gets straight out, so it can actually heat up a nichrome wire, a burn wire. So a nichrome wire is like a burn wire like this thing here. It's been used to, for example, if you have something that you want to, like a antenna on a satellite, or solar panel antenna or on a satellite, and they're like, spring-loaded, then you use the burn wire to release it. Or you just use a burn wire to kind of like take a fish line, like a nylon wire, and burn that over. Now, if you run the battery here on a nylon wire for like 20 seconds, you probably would run the battery flat, You have to calculate how much you can do that for. So typically, you just do it like for 3 or 5 seconds and released. You can also use it for other stuff, other high output stuff, but it actually just provides the power out on these terminals here. So you can choose what it is. Like, for example, if you say I want 12 volt here, and I have this 12 volt in on the PTO4 or on a PTO1, it comes out here. The last one is the input. So it's not like the input that we had on the XK01. It's another type of input. It's actually an I/O expander. But in the library, you can then test on the input. You might have some other kind of switch similar to you would have on the S02 and use that as input. So this is the O01. We have supported that in the code on the kits, on the XK07, XK90 kit. So there's support for that. What it does is that if the XK07 lies still, then one of these pins lights up, and what you can use that for is then you could put a buzzer on it. I think there's 1 or 2 pins that light up. There's a little light underneath here, a little LED that lights up, and that runs on normal 3.3 volts. So you can see if the relay is turning on and off. And you can put a buzzer on one of the terminals. You can put an infrared LED on one of the other ones. So if your your balloon flight have landed and lying still, then the XK07 kit will find that information on a IMU. The IMU will say, listen, we're not moving, we're lying still. And it will turn this on, and you will then hear a beep from the buzzer. If you have a buzzer, you click into this or screw into that so you can buy a buzzer. Or like an infrared LED, which you can see from a drone, or if you're flying, when it's not too bright, then you can put a normal LED in and you can see maybe the light from a distance, or if you fly over the drone, you can find that. So that's supported in the XK07, XK90 kit. So that's one there. We also support, or busy supporting, the SX01. Next up is the Raspberry Pi Zero bridge. So a Raspberry Pi Zero is this one here, not to confuse with one of the big Raspberry Pis. So Raspberry Pi Zero, it runs the same software, and this is the Raspberry Pi Zero headerless. So you can get them with header and without header. You need the headerless for this thing here, so it just have the holes. If you find the one that get one of those that have headers on, they look like that, there's a header on, and that's not good. Not for the bridge that we're sending to you. So the headerless is like that, and the reason why it's like that is that we have only 12 pins that have to be soldered, but you have to solder themselves. You're not getting the Raspberry Pi. What you're getting is a bag like that. And in the bag, you will have your little Raspberry Pi bridge. And that provides power also for the Raspberry Pi. So if you put power in here, it will provide power for the Raspberry Pi Zero. So you don't have to power it separately. And there's a little header like that that goes into the holes here, and you have to solder that together. If you get a Raspberry Pi Zero like that, then you can buy, it's not included, a standard Raspberry Pi bridge, the BR1, and you can just click it in, you know, from pin 1, similar to you will done on a normal Raspberry Pi. But if you get the headerless version like that, this is great because you can run NASA's CSF software, so NASA's satellite control software. You can run on the Raspberry Pi on the Zero here, and you can click that into your kit, and you can run proper NASA software on your Raspberry Pi Zero. You need to get the Raspberry Pi Zero headerless. You can also connect a camera to this, so if you want to fly with a camera, similar to I have on a picture here on the screen, there's a Raspberry Pi Zero, and I just put the camera on the back of the battery as an example. But you can get that if you go out and buy a Raspberry Pi Zero camera to this one here. Just remember you need a Raspberry Pi Zero camera cable. You can see on the picture below that it's a little bit narrow in the one end to fit with this thing here. So just remember, if you want to get a camera, get a Raspberry Pi Zero cable also. Then we have added the alcohol sensor. The only reason why we added that, because it's not really hardware special, is just it uses a lot of power. So it's a great kit to put it in. This thing here, you should only use if you really have a lot of power to use, because the way this gas sensor works is it heats up the element here and ionizes the air and then measures the alcohol levels. It's not a calibrated sensor, so you have to calibrate yourself. We're just giving a value with the ADC on the back from 0 to 255, but it's good enough to kind of like measure, you know, maybe if there's alcohol in the air or not, that kind of stuff. So a little to play with. And of course, it's alcohol, so it will also works with other gases that maybe contains a similar organic compound than alcohol. And finally, there is the PG01 Power Generic. And remember, if you want the power that you put into that, so you could put anything from 5 to 24 volts in, and it have to be DC, so it means you have to have a plus and minus, not an AC power. But if you put anything from 5 to 24 volt in, so let's say you put 12 volt or 13.8 from the car battery, and you solder that little thing up there, then you also get that out here. You get 3.3 volts as always, but on a V source here, you also get the 12 volts. So for example, if you want to power that up with something else that you regulate, then you can use this O01 and that power comes out on those pins. The nice thing about it is that there's no plus and minus here. Even though that your source have to be DC, you can put the plus and a minus into which one ever you want. So it's kind of like reverse polarity protected in a sense that it actually just reverses the polarity to the right way around. But you can't put AC in, it have to be DC, 5 to 24 volts. Doesn't matter which one you put plus and minus into. So that was the hardware extension kit. Now let's look at, and this kit goes for $125, and you also get 2 bags of connectors. You get a bag of these big connectors, 10 nails, and you get a bag of small connectors. There's 2 of these small ones. In this kit here, there's not a lot to use these for. You can connect it to the IX01 that uses these small pins here, but you can also use it in the other kit, even though that comes with small connectors also. But that's what you get in this kit here. So, next kit up is a software extension kit. Now, what I've done here is that I haven't put a Raspberry Pi on a picture because everybody knows how a Raspberry Pi looks like. So that looks like that, if you don't know. And this is the new Google Coral single board computer. So it have the same header as a Raspberry Pi, and that's a lot of single board computer have the same header. So header is, this output here. So Banana Pi, Orange Pi, those clones, there's a lot of other single board computer that said, no, we're gonna just use the same here. But you can see this one here is pretty flat on the board. So therefore we have this BIO1 that we can use to put into our Raspberry Pi. But you might want to use one of these other single board computers like the one that I have in a picture, the new Google Coral, with this AI compute engine. So it's like meant for TensorFlow and for artificial intelligence and things like that. And that's the reason why it's on the top have this big cooling element. You might want to put a cooling element on your Raspberry Pi. And for that reason, we have included instead of our Raspberry Pi bridge, we included our Raspberry Pi interface, and that looks like that. So here's the Raspberry Pi. You can see it sits like that instead. So it doesn't block anything that's here, and you address it from the outside. So you still put it in from pin 1 down, but you face that way. Don't face it the other way around. Face it out. And you have the pins here also, so you can use this as SWD programmer, JTAG programmer. You have access to bitband, SPI, whatever you want to use these for. And of course you have the normal pins. You also have a switch here, so you can swap these serial around, so you can swap the TX and RX around if you want to. A couple of LEDs here for indication. We use it a lot to, for example, if you want to put another bootloader on a CC03 or CS11 and things like that. So it's very universal, but you can see it also great if you have another single board computer than a Raspberry Pi. Then we also added a BeagleBone bridge. Now the BeagleBone Black looks like that, and the bridge also work on a BeagleBone Green, I believe. This is a BeagleBone Black Wi-Fi, so it works on a lot of them. It doesn't work on a BeagleBone Blue. I think doesn't have this header. So if you have a header, this is called P8 and this is called P9, and this is, in BeagleBone language, this is called a cape. Yeah, a cape they call it. Anyhow, we call it a bridge. And you plug it in from pin 1 here, and it, you have the same as you have with any of the other bridges, serial and I2C communication, so you can connect your chips. And Raspberry Pi, the BeagleBone is kind of like one of those single board computers that a lot of satellite builders like. It's kind of like another construction that apparently a little bit more useful in certain circumstances, I wouldn't say. But for example, there's a commercial satellite control software that's called Kubus, Kubos, KubOS, and that runs on a BeagleBone. So if you have a BeagleBone, you can play with that. Here's an extension for that. Then we have this IPO2 Dual Programmer. So we call it Dual Programmer because you can program all our cores with that. You can program the CW1 you already have in the kit. You can also program the CS11 you have in your kit. So here I have the CS11. So you click it in with 2 connector. You get them in the bag also. And then you put it in like that. And now you can program both of them. And you can see it says A and B here underneath. And there's a switch here that says A and B. When you program the CS11 and CC03, only those two, you use this one here. That's kind of like using the USB connection that is directly on the chip. So it goes straight from here to here. There's a FTDI chip in the back. It doesn't use that. So you have to have it in the A position like that. This one doesn't matter if you use this one. So that's how you program that. So it comes like that. You have the CS11 already. But you can also program the CC1, which is next down on our list. And there you just need one connector. The reason why the other one is there is because that is to load the bootloader. but you can't actually use the bootloader, load the bootloader here. You can do that on the IO1 you have, but there's a bootloader on already, so you don't need to do anything. It's the same bootloader there is if you buy an Arduino Uno. So I don't know where my Arduino Uno is, but it's the same as if you have the Arduino Uno. And actually it's more accurate to say the same as the Arduino Mini Pro, because the Arduino runs 8 MHz and the Mini Pro runs 16 MHz. So when you program this thing here, you just go in and say, I want to use the Arduino Mini Pro 5 volt 16 MHz. There's also one called 3 volt, but then it only run 8 MHz, and that 3 and 5 volt doesn't really matter because it knows. The important is that you choose the one that says 16 MHz. Otherwise, your clock speed is wrong when you want to run something that uses a clock. So that's the CC1, similar to the Arduino Uno. So whatever you can program on Arduino, you can do that, and you can program that. And you can also plug in your CW1 into that, and CS11, CC03, CW2, whatever we have of different cores, you can plug in and program that. But you get this CC01 also. And then you get a console battery, little one like this one here. It has if there's a battery in, which is not included, then there's a little switch here so you can turn it on and off. And of course, this is great if you have something that's low power. Now, low power you can do even on a CW1 that's Wi-Fi. If this thing here runs on the CW1 and Wi-Fi, you probably use the battery in 5-10 minutes. Very, very hungry. But if you just turn it on for like a second to upload some data and then turn it off again, and you do that once a month, then you can run a year on this thing here. So just make sure that low power can also just be that you go into low power mode or sleep mode for a while. So if you, for example, have something that just have to wake up, do a measurement like temperature measurement, send it somewhere, and then sleep again. Temperature doesn't necessarily change that very often, so maybe you just want to do it once an hour, or 6 times a day or whatever, then you can upload that. You can also connect it to your radio, the lower radio, obviously, and then have a similar low power circuit there that tend to be even lower power. Or you can maybe use it with your CS11 and write something to the SD card and then come and pick it up, end of the month and download the data. So use that. You can use the IX01 in a hardware kit to measure your current consumption using a normal voltmeter. Then we added this sensor here, the SD34. Now, when we originally built this thing here, that was our particle sensor. But the supplier of the chip have not released the software to use as a particle sensor. We can actually only use it for as a heart rate monitor. There's a couple of different things. Heart rate monitor, there's something with eye blinking monitor, there's like different things. So it's more like a heart rate monitor that we sell it as right now because that's what it can do. You put your finger on and it can kind of like make a heart rate a thing on a graph in Arduino. There's some excellent libraries, especially from SparkFun, where they use this one here. So that's the heart rate monitor. And then we added this little keyboard. So S801. Yeah, there we go. So this one here, it has like 4 different buttons, and we don't say ABC or 1, 2, 3 or something like that. We use symbols because then, hey, you can use it in any language. You can make your documentation and say, press circle for 1 and whatever it is you want to do. But they sit like that, so it looked like your PlayStation console, or probably any other, Xbox console, any of the other ones. But this is the way it works. It captures, so you just put your finger on. You can't actually see anything. There's a little chip on the back. And we have made a project on a Raspberry Pi where you use this thing here to play Space Invaders. So Space Invaders is on a little screen, and then you use thing here to move your little spaceship left and right, and you shoot with a triangle, and you start over the cross. So yeah, a little keyboard. And then the last one we just added was the MDR1, and the reason why we added that is that sometimes when you build a project and you maybe use 5 X tips, but if you just had one more, then it will be a perfect rectangle or square or whatever, however many X tips you use. So it just kind of like completes it. It helps making sure you have the redundancy, because it's always nice to be connected with at least 2 connectors. So if the one connector is loose or something like that, it always works. That's how when we build something that flies on into space, we use at least 2 connectors to connect all our things, so there's a redundancy and flexibility and can take that. So a spacer here is great for that. And you can get both of the kits for $199. So the one for $125, the other for $125, both of them for $199. There's shipping on top of that, so just be aware of that depending on where you are in the world. And thank you for listening, and by the way, feel free to ask questions and contact us if there's something that's not clear. Have fun.